an instruction how to create a Docker container. We'll see it in JSON format. You can create your own image or use other images created by other vendor for publishing registry. How do you create your image? Simply you create instruction file, which is Docker file. Okay, Docker file command. Image is a snapshot of file required to run application. We can use image which based on another image. For example, we can use images of another OS vendor, which can be Ubuntu, Red Hat, or Windows. They are very portable and consistent because they are only files. What is container? Container is running instance of an image. You can run as many images you want with container. They are isolated, but they can communicate outside the world. By default, they can access all the CPU and the memory resources, but we can limit it. We'll see the tricks next. Each container has writable layer up on the top, but all the container shared read-only image layer. You can start, stop the container, and do not affect the writable layer. It does not disappear. Volumes are file system outside the container where you put all your persisting for data, because containers are mutable. You can add container and container disappear and the data will disappear. So if you want to keep the data, for example, in database, we should use volume, which is external file system outside the container. So we talk about Windows container and Linux container. So you start a container, the container starts a process. The process is perform its mission, the process is finish its mission, the process terminate, the container stop. So database is not the ultimate solution for the container. You cannot use container to keep data in database because of persistence and performance. And what is Docker ecosystem? This is Docker system. It's look for this. This is the source. This is a client server application. You can see the client and the server. The server, it's Docker-D, the process Docker-D, which is persistent across that it's manage the container. So this is the client which run command with the command Docker. Call the server, which is Docker-D. The server pull container from the registry, public registry. You can see it here. All this use REST API. This is interface. Here's the REST API. That's interface that program can use to talk with the daemon. So here's the daemon. This is REST API. Docker architecture. So we talk about it. We have the Docker daemon, which is Docker-D, which is service in Windows. You can see the service here. It's system for the Docker API and request and manage Docker objects like images and container. We'll see it next, and networks and volumes. Docker client. This is Docker clients. This is the command Docker build, Docker bool, Docker run. It's execute command sent to Docker domain. It's like SMS in SQL Server. It's in Windows, it's PowerShell, and Linux, it's the shell like Bash shell. What is Docker registry? Docker registry store all Docker images. Docker Hub is a public registry that everyone can use. So you have Docker Docker Hub of Docker company, Microsoft, etc., etc. You have the Docker. You can create your own private registry. By the way, Docker push commands. It's push an image which you have created to the Docker registry. So what is the container lifecycle? Build, push, pull, run. Build, Docker build. It's a command. Here is the syntax with a Docker file. It's enable you to build container image using the command Docker file. Okay. Push. Once you build your image, you can publish the container image to registry with the Docker push command. So it pushes to registry. Pull. We'll see it. You can pull a container image, download to your local computer, run Docker run, which will run an image as a container with the command Docker run. So this is the link to the syntax. We'll see in the example. So you can use Docker command client to manage the monitor and interact with them. So what the available edition of Docker? Docker desktop, community edition. We see it's not free. We have for server, CentOS, Debian, Fedora, Ubuntu, all Linux flavor. Docker Community Edition for Azure. Docker Tools with its legacy. We have also Docker Enterprise Edition for Windows Server since 2016. All Linux flavor, and the Docker Enterprise Edition for Azure. What are installation choices? We can install Docker on, of course, on Linux flavor, and also on all the Windows flavor. But sometimes the installation of Windows are an issue, and we can run only Windows container on Windows Server. We, in this demo, will use Docker Desktop. Docker Desktop, it's good for the developer. It works with the Windows or Linux container. It works both with Windows and Linux container. You should use Windows Professional Enterprise Edition, and Hyper-V should be enabled. This is the best choice for developer. This is the link. We can see that it's not free anymore. You have personal, pro, team, and business. So what is the state of Windows and Linux SQL Server container? Very, very simple. Microsoft no more use SQL Server Express Developer Edition image for Windows container. They are not available anymore. You can use only SQL Server Docker Linux, which is supported on productions. This is the link why Microsoft terminated its Windows Server container. In previous lecture, I talked about Windows SQL Server images. SQL Server Linux image is very light, 1.5 giga vs Windows SQL Server 17 image, which is about 10 giga. It's very, very heavy. SQL Server 19, which is only available in Linux images, support all the previous version of SQL Server. SQL Server 8, 12, 4, 6, 1, 7 compatibility. So let's start with the demo. Let's start with the demo. Enough talks. So first we should install Docker Desktop for Windows. This is the link. If you want to install Docker Desktop on Windows, you should install WSL backend. What is WSL backend? It's Windows Service System for Linux installation guide for Windows. It's an emulator for Linux on Windows. Here you can see the basic command for WSL. For example, WSL -- install -d Ubuntu will install Ubuntu flavor on your computer. Okay, this is a screenshot. WSL -- list online will show you a list of distribution which WSL is support. So this is as this should be installed before you install Docker Desktop. What interesting about Windows Service System for Linux that you can use it for install another database system like MySQL, Postgres, Microsoft SQLite, MongoDB, and Redis on WSL. And the question is whether it could be alternative to Docker, because Docker is not free. And you can use WSL. On WSL, you can install all this flavor of database. Sometimes there's an issue when you want to install Docker, so you should install and run CCleaner. CCleaner will then install cleanly Docker Desktop, and then you can reinstall it again. This is the link to download CCleaner. So first we run Docker run hello world. Is the basic. If you run Docker run hello world, it's same as Docker run hello world latest, and this is the result. The client of the Docker will download an image of Docker run hello world and run it and then finish it. You can see it here. What is tag? Tag further identify the content of Docker images. So if you don't provide the tag, you always use the latest tag. For example, Docker run hello world is the same as Docker run hello world latest. In this example, we refer to Microsoft Container Registry, MCR. Microsoft has its own registry. In Docker registry, there's a pointer to Microsoft registry. So here you pull the latest version of SQL Server, Docker pull MCR Microsoft.com, SQL Server latest. Okay. Tip, always specify the tag so we know that we always pull down the latest image of Docker from Container Registry. Let's explore the Docker app. Remember, Docker app, it's like a storage. It's contain all the containers, all the images. So how do you get a list of available tags from repository Windows? So you should run this invoke web respect, HTTPS, MCR Microsoft.com, blah, 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 content. This will give you all the version of SQL Server on Linux which are available on Microsoft Registry. On Bash Linux, you should run the following: curl -SL, HTTP, MCR Microsoft.com, v2, SQL Server tag list. If you want to look for SQL Server container or Docker app, you can run also this command, docker search MSSQL, and you will get this. But this is better because here you get the specific all the version which are available on Docker app, on a Microsoft registry. Docker image command, the Docker image command for each image, it will show you the repository tag, image name, identifier, the image ID, creation date, and image size. For example, if you run Docker image, you will see that the repository tag, image ID, created, and size. Note that creation date, you can see it here, the creation date, it's not the date on which the image was created, it's the date on which the image was created, not pulled. So you can see it created. This image was created 3 weeks ago. So this is a common mistake. Sometimes there's an issue because we want to delete image with the same image ID, but with different tag. Here's an example on Docker images. You can see that we have 2 images with the same image ID, but they have different tag, SQL Server latest and latest. If you want to run Docker image RM and want to delete, for example, this image, you will get an error because there are 2 Docker with the same image ID. How do you remove them? Very, very simple. You should use Docker RMI -F, and here Docker images -Q. Docker images -Q will give you all the ID of the images which are available. And this is input to Docker RMI -F, -F, So this is a common example with how to remove images. Docker PS, show the currently running container. This is Docker PS. The status column tells us, you can see it here, Docker PS Docker PS. The status column, you can see it here, the status column, which tells us whether the container is currently running. You can see it here, status up to 4 hours. If container just run and doesn't appear in this list, and you don't get error message, it seems that the container ran, do its mission, and terminated. Docker PS -A display all the Docker container, both currently running and terminated. You can filter also the container. For example, Docker PS -F, -A, -filter, status created will give you all the only created container. Docker PS -A, -F, status running, all the running container. So this is a filter. How do you stop and run? How do you stop running container and remove all container and images? You cannot delete a running container. First, you should stop the container, delete the container, and thus you can delete the container. So Docker RM -F. Same, this is like a kill command in Linux. It is not recommended. This will kill all the running container and delete them. But the right way to do it is, to delete the images. Docker image RM, image ID, Docker image RM, or image name. So again, so you cannot delete the image. If container uses image, so you first must stop and delete all the container using before you delete the image. So you can see it here, Docker images, list all the available images. Docker images -Q will give you the ID of the images which are available. Docker RMI, Docker images -Q. Docker images -Q will give you as an input the ID for all the images we have now. Docker RMI will remove them. Again, if there is a running container, you cannot do it. So this is example how to stop container, remove container, and its image. Docker will now run in container. We'll talk about the command later. Docker run -name, SQL latest is name of container, host name, the host name of the container, -p, -c accept ULA, I say password, and this is the image. So this will run in command. I will talk about the command later. Docker PS will show us that the container is running. Docker container -a, it's another way to show in the format of the running container. Docker images will show us the image we have pulled down for the hardware. This is the image we've pulled. Docker stop SQL Server lattice will stop the container. We'll call him SQL Server lattice. Docker run SQL Server lattice mean remove the container. Docker PS show the running container. Docker images show the images we have pulled down. Docker images RM, and this is the name of the image. We'll move the image. So this is the way you move. You stop running container, remove container, and its images. Stop the container, remove the container, and then the images. So this is the example here on PowerShell on your PowerShell window. See it here. But there is trick. With one line, you can stop and remove all the Docker container and unused volumes. So how this trick move? So Docker container ls -a, -a or -all mean show all the container. Remember that if you write Docker container ls, it will show you only the running container. Docker container ls -a will show all the container, including the terminator. Another trick is to use Docker container ls -a format table name image status port. This will give you a handy template for presenting a running container with name image status port. How do you get the container ID? Docker ps -aq will give you the container ID. And now Docker stop, Docker ps -a-q, the input to Docker stop is all the container ID. Docker ps -a-q will give you all the container ID. This input as to Docker stop. Docker rm ps -a-q, again, this remove all the container which the container ID has an input. Docker ps will show us all the running container. Then we'll talk about it. If this container use volume, you can move all the unused volume. Volume is external file system outside the container where you can save data. So Docker volume prune -f will use all unused local volume. How do you delete all the images? Docker images will list all the images. Display all the images ID, again, the same trick, Docker images -q, you can see it here. Remove all the images, Docker RMI, Docker images -q. Docker images -q will give you all the images ID. This is the input to Docker RMI. This is the trick. And then we can remove again all the unused local volume, Docker volume prune -f. So this is the trick to delete all the images in one shot. So how do we, in several line of code, we stop running container, remove the container or the images, Docker stop, Docker ps -a-q. Docker ps -a-q will give you all the Dockers, all the containers ID, including running and terminated, Docker stop. Docker rm will remove them again. This will give all the ID. Docker RMI, Docker images -q. Docker images -q will give all the ID, all the images we have downloaded to my computer. Docker RMI will remove it. Docker PS will show all the running container. Docker images will show all the images. Docker volume prone -f will remove all the volume. You can see it here. So you can use this line of code to remove all the container and all the images to clean the environment. Docker inspect. What is Docker inspect? Docker images will show the images. Docker inspect image ID. For example, if you want to search for a JSON text, if you want to find out which version of SQL Server you have downloaded with the image, you can use Docker images. So, image is a JSON file. So if you're searching JSON file for the section called label version number, you can see the version of SQL Server. So you can see it here, Docker images, Docker inspect, and if you go to label, you can see the product, which is SQL Server, and the version and the vendor. Note that Docker manifest inspect and Docker inspect command are functioned differently. Because to export manifest list or image manifest, you use Docker manifest. We'll talk about it later. If you want to export low volume data of the Docker like here, you can use such as images or container. We use Docker inspect like here, Docker inspect. What is context DBAS? Very, very simple. When you download an image of, when download image, there are the file layers, there are layer of file system. Each layer has hash value. This hash value is compared with the metadata of the image of metadata of the JSON file of the image. So in this example, you can see that this DGuest is the same as the DGuest here. This is guaranteed the integrity of the file system. So if we pull file system, we go to the JSON metadata and see that the hash value is the same, and that's will ensure that we get what we wanted. So you can see it here. Docker images are minus MCR Microsoft.com, blah, 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 blah. Docker pull, and then we pull the latest version of SQL Server image. Docker images will show the images. Docker inspect, and this is the image ID. We can see it here that you can see that the biggest here is the same what is described in the Docker inspect in the metadata. If you run Docker inspect MCR Microsoft latest, you will see all the file system of SQL Server under this layer section on image. See it here. What is distribution hash? Because when we're working with file system across network, file is compressed to improve network bandwidth. So hash in the layer section when you run Docker inspect command for the image is in uncompressed. You can see it here, Docker inspect. You can see the hash value. This is the hash value of the uncompressed file system. But if you use Docker manifest inspect and then the image, you will see the biggest field of the image manifest of the compressed file system. You can see it here. So there is difference between this hash value and this hash value. So this is the difference between Docker manifest and Docker inspect. What is image manifest? Image manifest or FAT manifest. It's provide detail of different file system layer to build image and configuration. Manifest list, it's metadata for different platform on the same JSON file. Okay, it provides single user experience for multi-architecture supports. So in the same JSON file, you have description for all the operating system. Therefore, it's called FAT manifest. But SQL Server do not support manifest list. Why? Because SQL Server support only x64 compatibility for SQL Server 17 on Windows, on Linux. But on the other hand, azure-sql-edge, which is a small footprint, edge optimized for SQL database engine with built AI, support manifest list. Let's see it. So how do you know that image is FAT manifest? It means that it supports all the operating file system in the same JSON file. Very, very simple. You should have here media type, application, VND, Docker, distribution, blah, 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 list vJSON, and schema version 2. So, for example, if you run Docker manifest inspect hello world, you will see that it supports Linux 86, AMD 64, Windows version, and Linux. Why? Because you can run Docker run on world on each operating system. And this is FAT manifest. You can see it here. The same JSON file describes all the operating system. Here is the context digit of image manifest for Linux while manifest. For example, for azure-sql-edge, if you run Docker manifest inspect MCR Microsoft.com azure-sql-edge, you can see it here that this is also FAT manifest. The same JSON file describes several operating systems, Linux AMD 64 and Linux on ARM. So more on pulling FAT manifest. Docker daemon, if doesn't have a local of a load to a container image, it's a Docker hub for the image. You can see it here. If there is FAT manifest, the FAT manifest go to the section of the Docker daemon platform information. It look for the platform here, and then image manifest is first reading and giving the appropriate file system for this operating system, and it will download to this computer. So this is FAT manifest. How do you save Linux Docker images of files on Docker desktop? Very simple. As you see example, Docker images show the images. Docker image RM will remove the previous image. Docker pull MCR Microsoft Kubernetes server latest will download the image to your local computer. Docker image will list the image. Now this is the magic. Docker save -o, and I will save it as the file C Docker images SQL Server 19.docker, and this is the image MCR Micro which I have downloaded. Now I can take this file, copy it to this connected computer for the network, and how do I load a file of image? Docker load --input, and here the path to this file. So this is the example here. You can see it here, the image which is saved as a file on your local computer, and is good for computer which is disconnected from the network, because I can take this image and move it to this computer. Just a minute. So you can see that if running here Docker pull MCR Microsoft latest, each pull complete represents a file system, and each file system is 64 kilobit. You can see it here. You see it here. So it's represented by hexa representation. So 64 character bit, and this is hexa. You can see this. Each one is file system. What is unit file system? Unit file system, very, very simple. Container image is read-only because it's template. But when container is running, we have a writable layer up here. This is up layer. So all this is read-only. And if you want to write, we have thin write layer. So how do you do this magic? It's copy and write technicals. You can start a lot of container from the single image, but unit file system take all the file system which we have downloaded to our local computer and create it as a, but the container see it like a single unified file system here. For the Docker point of view, when the container is deleted, this writable layer will delete. How to implement this? By storage driver. On Linux, it's overlaid too, and this is on Linux. Let's look at file directory's name. So each file system layer that get put from the Docker up to your local computer is stored on your local computer, or this layer. The location of the file system layer in local disk depends on the storage drive. So how do you find it on Linux? Docker info grep -w storage drive. You can see it here. This is the location where all the file system which build the unit file system is installed on the local computer. Varlib docker overlay directory. On Windows Server, you use the following command in PowerShell docker info, select string storage drive. You can see it here. On Windows Docker Desktop, it installs C program Docker Windows file filter. But if you run Docker info select string storage drive, I will get this strange error. So if you're going to if you are going to display system-wide information, you go to this on Stack Overflow. It will say you it's okay. You should not treat this. But Docker info, if you run here Docker info, you can see all the information about the file system. So again, Docker works. So let's talk about Docker file system. How it's built with your database, with the SQL engine dependencies, and based OS image. This is SQL Server file system. But what happened when you modified, when the container need to write, when you need to do a write operation? When an operation is requested, the file system drive find the layer you need to write it. If the layer is not, if the file is not on the top layer, unit file system will perform a copy up operation. Simple, it will go to the directory where all the file system is stored on the local computer, and will copy all this layer to the top of the container. Once the file is copied, the changes performed. this can take a lot of time. Why? Because we do copy and write. We take all the file system, copy it, and then do the write. So subsequent changing made to the file will be written to the div directory of the read-write layer. There is a directory which named div directory. But it's very, very heavy operation. Why? Because SQL Server can use snapshot. In snapshot, only modified record is copied. Docker, on the other side, copy all the entire file system. And when there are changing, it will record all the changing in the directory of the div directory. So it's very, very easy and efficient when working with large and write-intensive processes like RDBMS. So let's show you how do you run SQL Server Linux on image on container. Remember, we cannot run any more Windows image, only Linux SQL image. So first you Docker PS, Docker stop SQL Server latest, Docker RM, SQL Server latest, Docker volume ls, Docker volumes RM SQL volume, Docker volume s. This will clean all our environment. This will kill with stop any running container which is named SQL Server latest, remove it, remove the volume. And now this is the magic, only the few lines to run SQL Server Linux image on container. Docker run -c, except ULA, -c SA password. This is the password. Memory, this is the memory. -p or port 143.143. -name, the name of the container. Host name, this is the name of the host. -mount source, SQL volume, target, var, PTM, SQL. -d, enter Microsoft SQL Server latest. So once we run it, we'll now take about the syntax. Docker PS, check the container is running, the volume was created. This is Docker PS. We can get a more format, ND format with Docker container ls format, table, name, image, status, and port. Docker volume ls, Docker volume is spec SQL volume. This will show you the volume properties we created with this container. You can see it here. Okay. So let's talk about each parameter. -e parameter, it's mean specified environment variable that container need to execute. At the minimum, SQL Server need this parameter, except ULA, this is mean except license term, -c, this is password. So you need to accept ULA agreement and SA password minimum. There are a lot of other environment. You can specify, for example, SQL Server Edition or enable SQL Server Agent. If you go to this link, you will see all the environment you can use. So you can use it with -c or the environment variable for your environment. Other option is to use environment file. How do you use environment file? -env -file, and this is the location of the file with environment variable. So you can see it here that Linux image is very, very flexible. A lot of environment. If you go here, you can see all the environment you can use Linux SQL Server image. -p1433 -333. It's mean publish -publish the container port to the host port. So it's mean allow to connect to the SQL Server instance in the container from a remote client. So the port 1433 on the container will be published as port 1433 on the guest host. Okay. Remember that if you want to use a lot of SQL Server instances in SQL Server on Linux, there is no named instance. So if you want to create another instance, we need to map if you want to create another SQL, we need to map the port 1433 to another port on the host. So 1433 is the default port of SQL Server. -name SQL Server latest, it's not required, but it's very convenient. This is the name of the container. And for convenient, this is the host name, SQL Server latest. It is the same as the name of the container for convenient. So if you go to SQL Server and run should server name, it will be the host name. -start and let's stop, it's a magic, like a service, automatic service. It means that the container will stop automatically when the computer will start. You don't have to restart it. So this is also the combination of Docker, because it tells us do not use any external process to start the container. So -z mean run the container in the background. But if there are problems, another debugging technique is to remove this flag. So if you remove this flag, you will see all the error log dump, the content error log, to your stdr, to your CMD screen. And you can use by this way to find a problem with your container without the -d, detach in background. You see also the Docker log, we'll see it next, to dump the error log of SQL Server container. -mount source SQL volume specify that SQL Server volume we use external file system to store the database. Why? Because images container are immutable. They disappear. One disappear, or that disappear. It means that container will keep all the data outside the container. So it will be persist. So if you write here -mount source SQL volume, it means that var opt MS SQL data, which is the will be outside the SQL Server. Another option is to use the -v. It's CMS SQL var opt MS SQL data. This is another option. Both parameters create directory out on the Docker hosts. It's in case it's not already exists. So what should we use? -v or -mount? So -v parameter came first, but -mount parameter is more recommended because its syntax is easier to understand, and it consists of key and value pair. -mount is recommended to use for new deployment. If you use SQL Server on Windows, you can use the -v, but it's not anymore supported. So you should use -mount source SQL volume. Volume cannot be shared between SQL Server container. If you run two containers of SQL Server and both use the same volume, you'll get error, because if you start a new container attached to existing volume that another SQL Server container doesn't exist, you'll get an error 14133, because SQL Server process catch the database file. You can see it here. Docker exec command. Docker exec command enable you with the -i interactive and -t terminal to go to the bash of the Linux, bin bash, and do some command. In this command, we will see that if you use ps-xf, will list all the running processes. In SQL Server, the only running processes is two SQL Server processes, bash shell and ps command. If you go to Linux and run ps-xf, you will get a lot of processes. So you can see that if you, on Linux container, it's highlighted that the container is isolation, as highlighted that the container processes are isolations. Container and its running process cannot see any process running on the base operating system, on the guest host. ls -l var opt SQL data, this is a default directory for SQL Server on Linux. If you grab type exit, you'll go out. So you can see it here. Docker ps. See it here. Docker ps will show us all the running container. Docker container ls format, table name, image, status, port. This will give us handy about our container we have created. SQL Server latest, image, status, port. Docker exec -it SQL Server latest bash mean go into this Linux and use the bash. Bash is like PowerShell on Windows. pwd show us the current directory. You can see it here. var opt MS SQL. ls var opt, you can see it here. ls -la var opt MS SQL. ps-xf will show us the process running in the container. But you can see it here that we have only two processes of SQL Server. The command ps-xf and the bash. The bash is a PowerShell. This is the only process in container. It is isolated. Hostname, give us the hostname. Remember, hostname is the name we'll give to the container. Hostname, SQL Server latest. Exit will mean exit. We can run command without going in the bash shell and then get out using docker exec SQL Server latest. You can see it here. So it will give us the name of the container. Docker exec SQL Server latest ps-x. It will go to SQL Server container, run the command and get out. You can see also the result here. So By default, if you run container, there are no resource constraints. So SQL Server will use all the memory available in the system. How do you do it? How do we reduce this? Remember that we have run the container with -m or minus memory equal to 048 memory. This is the maximum of memory that will give the container. So this is a resource. -1 CPU will show how much CPU available CPU resource container can use. How do you change it on runtime? Docker stats will show us all the resources which the container uses. And then we can on runtime tell is use only 2 cores. How do you do it? Docker update SQL Server lattice -1 CPU 2. And if you run Docker stat, you can see that only 2 cores are used. So here with this command update, you can on runtime change the resources of SQL. If you go to this link, you will see all the command. You can use also GPU with container. But this how do you copy backup file to the container? Because of security reason, SQL Server process inside the container runs under user MS-SQL. But all the file systems are owned by the root. So how do we do it? Docker CP backup worldwide report full backup. This is the path to the file system. SQL Server latest. This is our container name. var operating SQL data. This is directory on SQL Server. And then I have to change. The permission to Docker exec -u root SQL Server latest show name SQL var operating SQL blah blah blah. It's mean change the ownership of this backup file which I have copied from connect as root. And this is the host name, and change the ownership to MS-SQL. If I will not change the ownership to MS-SQL, I will not be able to use it and restore the SQL Server backup. So Docker exec -u root SQL Server lattice show on MS-SQL mean change ownership to MS-SQL. var operating SQL data wide over full backup. This is the path to the file. Docker exec -lt SQL Server lattice bash mean go to the bash. Unless -la var operating SQL data blah 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 bookkeeper will show that the permission have changed to MS-SQL and then exit. So you can see it here. You can see it here. Docker exec itls bash and then docker ls var operating MS-SQL data. You can see that the owner of this file is MS-SQL. If you will not do it, you cannot restore the backup of SQL. If you go to this link, this is the explanation. Non-root SQL Server 19 container. It's only in SQL Server 19 container. So once I've done it, I'm only going to the SSMS and then right-click restore database and tell him var operating SQL data will full backup and restore the database. That's all. Here I connect to localhost, SA, and the password. I don't have to tell what's the port because I use the default port 1433. And then I can copy file out the container, Docker CP container path, host path. So, for example, Docker PS show as any container, and then Docker CP SQL Server latest. This is the name of the container. var operating MS-SQL log will take all what's in this directory and copy to local directory c.docker. You can see it here. Very, very simple. How do you explore the container log? You can use spread log or Docker logs. But Docker logs is much better. spread log, go to SQL Server logs and read all the error logs. For example, if you want to know all the failed login, you go to SSMS to your container, connect to container and run exec sysx spread log, login fail. We give us all the failed login in your SQL Server. But Docker log is better. Why? Because you can use Docker log command with the -f parameter to review SQL Server error logs in real time. So Docker PS -a will show as running container, Docker log containerized -f, or Docker log container ID -f. And this is the example. Docker PS -a will show the running container. Docker log, this is the name of the container -f, will show us in real time the log of SQL Server. You can see it here. And this is, for example, if on Linux you give a very weak password, the SQL Server in Linux will not start. How do you know it? Because if you run the command docker log container name, you can see it here, error, unable to set system administrator password. You can see it here. So this example, I will use Docker logs. And this is this is example with the password complexity. The same example, you can see it here. I run here Linux container with weak password 1 2 3 4 5 6 docker ps -s docker logs, and you can see that we get the same error. We found it with docker logs. About networking with standalone container, you can use the default bridge network. It's not the best choice for production system. You can use user-defined bridge network. You create your own custom bridge network. By default, you can see it here. Docker create a pair of virtual adapter. You can see the virtual adapter every time container is running. And this is attached to the bridge network. So network, you can see the network diagram. The default bridge here, default bridge network connect to the Docker 0 on Linux. On Windows, it's NHS on internal window. On the top of Docker 0, there is the bridge. You create your own implementation of network drive. So this is network with standalone computer container. So let's see how you see it. Docker network ls will list all the network. Now we'll run another container with a different bridge network. We didn't create any custom network. Docker run -m SQL Server latest -n SQL Server latest 1. This is another container. -p. Remember that we cannot run two containers on the same port, so we create 1433 and map it to 1401. And this is another container we run, and we map port 1433 to one port 1401. This is another container. Now we want the container to check the container running. Docker container ls -a format table name image status port. Now we'll see the port mapping. Docker port SQL Server latest and Docker port SQL latest 1. Remember that this use 1433 and this use 1400. We can inspect that. We can get the IP address of the container. Docker inspect SQL Server latest -format networking setting IP address. And the same for the other container. We can inspect the default bridge network with Docker network inspect bridge. Let's see it here. You can see it here. So you can see it here. Docker run. We run another container, and then container ls -format table name image status port. We can see that we get any format of the name image status and port. Docker port SQL Server latest. So you can see that we use 1433. On the other Docker port SQL Server latest 1, port 1400. Docker inspect SQL latest for what? Networking IP address. Will give us the IP of our SQL Server latest container. The same for SQL Server latest 1. Docker network ls will show us the default network. Network. So let's see another exciting. I don't have too much time. Smart SQL Server 19 in place and grid. So very, very simple. A great benefit of using our system in Docker, we can keep system and database in the same location, and we can update the SQL Server instances. But instead of installing SQL Server update, we only switch between the version of the container. We can do upgrade, but no downgrade. Let's see the example. It will be more clear. Let's see the example. Docker PS. This is all the running container. Docker stop SQL Server latest 1. Docker run SQL task will stop this container, remove it. Docker volume ls. Docker volume rm SQL volume will remove the external volume. Docker volume ls invoke web request HPP MCR Microsoft VM SQL Server tag content will give us all the version of SQL Server. Now we choose to install. We'll pull Docker pull NCR Microsoft com SQL Server latest CU8 on Ubuntu. This is the image we pull, Docker images. Now we'll run this image. Docker run -c except tool, as you know, but here we are doing persistency. -mount source SQL volume target var operating master scale. It means that all the data of this container will keep outside the container. For persistency. So var operating master scale will map to SQL volume. And we'll run this version -d SQL Server latest CU8. So we run this version. So you can see it here. Now we connect to SQL Server and then run select server name and version and SQLDB, and we'll create a test DB database here. You can see it here. So this is the version which is SQL Server 19 CO8, and now is the magic. Docker stop SQL Server latest. And now we'll run another container with higher version. Docker run minus restart unless stop, minus accept rule, minus password, minus P, this is the port, minus name SQL Server test NAS, this is another container, minus hostname SQL NAS, but this is the magic. Minus mount source SQL volume target var operative SQL, it's mean map to the same volume as the previous container which we have stopped. Minus D mean run it in detached mode, pull the latest version of SQL Server latest. So this SQL Server will connect to the database. Now, if you try to connect to the container, for several we'll get this error message. You cannot log to SQL Server because the SQL Server is in upgrade mode. Once the container has upgraded all the database, which will on external volume, SQL volume, if we will be able to connect to SQL Server, and then select server name version, we'll see that SQL Server version was upgraded to SQL Server 19 RTM CU12. And the only what we did here is to switch between the container. The same container are mapped to the same volume. So this is the process. So you can see that also the database was upgraded. Also test DB, the database was created, is kept because it's kept outside the container. So this is the smart SQL Server 19 implicit great. Why? Because we mapped var operative SQL, which contain data, logs, and secret data, directory of data files, log, directory containing SQL Server error logs, trace files, etc., secret directory containing the SQL master key outside the SQL Server. And we're telling the container to map to var operative SQL directory inside the container to SQL volume. So this is very, very tricky to do a smart place upgrade. You cannot do downgrade. Have time?